Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on unique paths. It's a dynamic programming problem. Let's jump into the problem statement, understand it and start coding. Okay, last time we solved the longest palindromic substring. You can find it in the list. Let's start with unique paths. Okay, there's a robot on M cross N grid. The robot is initially located at the top left corner, as we can say. There is grid 0, 0. The robot tries to move to the bottom right corner. There is this M-1, N-1. The robot can only move either down or right at any point in time. Okay. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. Okay. The test cases are generated so that the answer will be less than or equal to 2 raised to the power 10. 2 into 10 raised to the power 9. Okay. Now, before we proceed, okay, we have to, before that, we have to find all the unique ways from where this robot will reach from the starting position to the ending position. And the robot can move only in the bottom and the right direction, right? Let's see. Can move either down or right. So if we take the robot in this direction, right, down, it meets it. We take down, right, it meets it. We can take down, right, it meets. Then down, right, down, right, it meets it. But what we cannot do is we cannot have right, down, left, down, right. We cannot have left and upward movement. Okay. Now, this is the problem statement. So before I proceed, please take a minute and think of the approach that you will take. Ready? Okay. So one of the most basic approach would be to use backtracking, where we try with all the possibilities one by one. But there we have to compute, right? The other is using the dynamic programming. What we can do with dynamic programming is we solve the base problems and then we build upon them. Okay, like in this case, let's say if the finishing line is at any point in this row. If we wanted if the robot wanted to reach this quadrant or this point or this point or this point or anywhere in this first row, the unique path will only be one, right? Because it can only move right. It will move right for this. It goes this to reach here. It goes this to reach here. But the unique path will only be one. Okay, so that is clear. Similarly, if it has to go down anywhere in this column, the unique path will always be one. Now, what would be the answer for this box? If you see, you can come here by right, down, that is one path, down, right, that is second path. So solution for this one is 2. But if you notice, solution for this one was 1 and solution for this one was 1 as well. So I can say, means we can actually initialize all the rows as the unique answer would be 1 and all the first column as a unique answer would be, unique path would be 1 and first row as the unique path would be 1. And then at any point in time I can say dp of I j is equal to, so for this case it was 2 which is 1 plus 1. I am saying dp of I minus 1 and j plus dp of I and j minus 1. So for this position I am saying, if we know the solution, right, it is one path here, 2 is the answer. 1 was the answer for this one, 1 was the answer for this one. So this one is 1 plus 1 2, right? But let's verify it further. What if I want to check for this exact position? I know that we could have come here like this. This would be one path, right, down. Second could be down, right. Third could be right, down, right. So overall answer is 3. With this solution, with this formula, we see we are writing dp of I minus 1, which is I minus 1j, which is this one. The last solution here was 2. dp of I j minus 1, the last solution here was 1. So 2 plus 1 is 3, and that is the solution for this, right? So we have figured out the formula, and we have confirmed that first we initialize the row, the first row and the first column. After that, dp of ij will be dp of I minus 1j plus dp of I j minus 1. Okay? Very simple, right? This is how you always form a formula for any of the dynamic programming. You don't solve all the sub problems, but you build upon them. Okay? Okay, let's start with coding. Okay, so we'll create a 2D array to store the number of unique paths, which will be a dynamic programming. Which will be a DP array, each cell DP. So we can say int dp is equal to new int m cross n. Okay, now as I mentioned, first we'll initialize for the first row and the first column, top row, left column. Okay, so we can say initialize the top row and left column to 1, right? Since there's only one way to reach any cell, right? If we wanted to reach any cell, any box in this cell or box, it's called cell. Cell in the top row or left column. So we can say for int I is equal to 0, I is less than m, I plus plus, dp of I, and this one will be constant, 0 is equal to 1. Similarly, we'll do it for the row. We want to do it for the row and the column, right? So we did it for the row, now we'll do it for the column. Int j is equal to 0, j is less than n, j plus plus. Okay, so dp of 0 and j is equal to 1. Okay, right? Now we are just going to complete the array using the formula that we formed in the beginning. Okay, so we can say fill the rest of the array based on the number of paths from top left cells, top and left cells. Now, one more reason how you can arrive at this formula is, let's say we are looking for this particular cell. At this point in time, all the unique paths that the bot could have taken to reach this path. After that, he would take only down to reach here, and all the unique paths the bot could have taken to reach this cell, and after this the bot would take only right to reach this final cell. So we know to arrive at this cell we could have arrived from here and from here. So all the unique paths from this side plus all the unique paths from this side. Now all the unique paths from this side are already stored in dp of I j minus 1. All the unique paths on this side are stored in dp of I minus 1 j, right? That's why dp of I j is dp of I minus 1 j plus dp of I j minus 1. Okay, so we'll say for int I is equal to 0, I equal to 1, we have to start from the 1, I is less than m, I plus plus. Similarly, for int j is equal to 1, j is less than n, j is less than n, j plus plus, right? dp of I j is equal to dp of I minus 1 and j plus dp of I and j minus 1, right? And in the end, the solution will always be stored in the last cell of dynamic programming array. So we can say the bottom right cell now contains the total number of of unique paths. So we can simply return dp m minus 1 and n minus 1. That's it. And of course the overall time complexity would be m cross n since it's a grid. Let's run it and hope we do not get any compilation issues. It is running slow. Oh, great. Let's submit. So this is a very intuitive approach as well. Okay, great, beats 100% of the users with Java. That's great. I was hoping that everyone or most of the people would have chosen this approach, but that's good. It's very intuitive, plus it's a good fix with the dynamic programming. Okay, that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.